Scientists communicate their experimental findings in journals and other periodicals for other people to see, analyze, and interpret. Almost always, they will have to report data that are either too small, like the size of a cell, or too large, like the distance between planets, to be written conveniently and aesthetically using only the traditional decimal system. In this video, I will discuss scientific notation. Scientific notation is a simple way to write and keep track of very large or very small numbers without having to deal with a lot of zeros. So it provides a convenient way of recording results and doing calculations. So we have here some key points in writing a number in scientific notation. Scientific notation is in the form the uppercase N times 10 raised to the lowercase n. The decimal point in the original number is moved to the right or to the left so that only one non-zero digit is located at the left of the decimal point. So the main goal is that there should only be one non-zero digit at the left side of the decimal point. When we say non-zero, these are not zero. Numbers without a decimal point is understood to have 1 after its last digit. And lastly, if the decimal point has to be moved to the left, then the lowercase n or the exponent is a positive integer. On the other hand, if it has to be moved to the right, then the exponent will be negative. So for us to further understand on how to write a scientific notation, let us have a couple of examples. Example 1. Express 568.762 in scientific notation. So the decimal point is located between 8 and 7. As I have said a while back, the main goal is that there should only be one non-zero digit on the left side of the decimal point. Therefore, we will move the decimal point 2 units to the left. Since we will move it to the left, then the exponent will be positive. So that will now be 5.68762 times 10 raised to 2. So our exponent is 2 because we moved the decimal point 2 units to the left. Another example, express 0.0000772 in scientific notation. So that is not yet in scientific notation because the digit on the left side of the decimal point is a zero number. Therefore, let us look for numbers that are non-zero. Therefore, we will move the decimal point to the right. So we'll be moving it 6 units to the right. So that is now 7.72 times 10 raised to negative 6. So the exponent is negative 6 because we move the decimal point 6 units to the right. And lastly, express 602,200 in scientific notation. So as you can see, there is no decimal point on that whole number. But it is understood that there is one right after the last digit. So the last digit is 0. So we'll be moving the decimal point 5 units to the left. So that is now 6.022 times 10 raised to 5. So that is on how to write scientific notation. Now, let us proceed with the mathematical operations involving scientific notation. In chemistry and in other fields of study, Numbers that are very small or very large are converted to scientific notation before any mathematical operation is carried out. So we have four fundamental operations involving scientific notation. Let us first discuss addition and subtraction. Before adding or subtracting scientific notation numbers, their exponents must be the same. The numbers are then added or subtracted and the exponent is retained. So in adding and subtracting scientific notation numbers, we need to make sure first that their exponents are the same. Then after which, just add the numbers, then copy the exponential numbers. For example, let us add 1.4 times 10 raised to 2 plus 2.30 times 10 raised to 3. So it is either 1.4 or 2.3 that we will transform so that they will have the same exponent. For example, let us transform both of them so that they will become raised to 2. So first, copy 1.4 times 10 raised to 2. Then as you can see, we have 2.30 times 10 raised to 3. So we have the exponent 3. What is needed so that the exponent 3 will become 2? So we need to subtract 1. That is negative 1. Therefore, we will move 1 unit. We will move the decimal point 1 unit to the right. So that will now become 23.0 times 10 raised to 2. Since they have the same exponents, then let us add the numbers. So 1.4 plus 23.0, that is 24.4. Then copy the exponential number which is 10 raised to 2. So that is not yet the final answer because that is not in scientific notation. Because the main goal should be there is only one non-zero digit on the left side of the decimal point. So let us move the decimal point 1 unit to the left. Then let us add the exponent with 1. So that is now 2.44 times 10 raised to 3. Another example, let us have an example on subtraction. So we have here 1.30 times 10 raised to negative 1 minus 9.6 times 10 raised to negative 2. For example, let us transform both of the scientific notation into raised to negative 2. So in this case, we need to transform negative 1 so that it will become negative 2. So what does negative 1 needed so that it will become negative 2? So it needs negative 1. Therefore, we will move the decimal point 1 unit to the right. So that is now 13.0 times 10 raised to negative 2. Then, copy minus 9.6 times 10 raised to negative 2. Then, subtract the numbers. So that is 13.0 minus 9.6. That is 3.4. Then, copy the exponential numbers or exponential number that is times 10 raised to negative 2. Next, we have multiplication. The numerical parts are simply multiplied and the exponents are added. So in multiplication, there is no need for us to transform the scientific notation so that they will have the same exponent. So we just have to multiply the numbers, then copy 10, then add their exponents. For example, 4.2 times 10 raised to negative 1 times 2.3 times 10 raised to negative 3, first, we need to multiply the numbers. That is 4.2 times 2.3. Then copy 10. Then raised to negative 1 plus negative 3. So we need to add their exponents. So 4.2 now times 2.3, that is equal to 9.66 times 10 raised to negative 1 plus negative 3, that is negative 4. So the final answer is 9.66 times 10 raised to negative 4. And lastly, we have the division. Just like on the multiplication, we need to divide the numerical parts, but the exponents will be subtracted. For example, let us divide 4 times 10 raised to 5, divide it by 2 times 10 raised to negative 2. So first, divide the numerical parts. So that is 4 divided by 2. Then copy 10 times 10 raised to 5 minus negative 2. So 4 divided by 2, that is 2 times 10 raised to 5 minus negative 2, that is equal to 7. So the final answer is 2 times 10 raised to 7. So that is scientific notation. Thank you for watching, and I hope you have learned something.